I'm Anil Kumar, sharing with you some excellent questions which will help you to prepare for the test. Let's review polynomial division. The question here is f of x equals to x to the power of 5 plus y to the power of 5 divisible by x plus 5? Justify your answer. You can pause the video, answer, and then look into my suggestion. Well, I'll give you a couple of explanations for this question. Those of you who know remainder theorem, we can justify this with the help of remainder theorem, right? Which says the function is divisible by x plus 5 if f of minus y is 0, right? So if I substitute instead of x minus y, what do I get? I get minus y to the power of 5 plus y to the power of 5, and since this is odd, it is minus y to the power of 5 plus y to the power of 5, and we do get 0. Since we get 0 for f of minus 5, we say x plus 5 is a factor of the function given to us, right? Therefore, x plus y is a factor of f of x, correct? So that's the explanation which you can give using remainder theorem. So what we applied here is remainder theorem, or you can also say factor theorem. So factor theorem says that x plus y is a factor of the function f of x if f of minus y is equal to 0, right? Or the remainder is 0. Now the other way is we can just divide and check it out. Okay, so let's divide and check. So that is probably the best way to do it, right? If you don't know factor theorem. So when you're dividing x to the power of 5 plus y to the power of 5 by x plus y, we can write x plus y here, and then x to the power of 5. In between, a lot of terms are missing. X to the power of 4 is missing, so we have to write with 0, right? Plus 0x cubed plus 0x squared plus 0x, and then we have the constant, which is y to the power of 5. Okay, so we'll do long division. You can also do the shortcut method, right? Synthetic division for the same. So let's continue. X to the power of 5 we have to get, so we'll multiply by x to the power of 4. We get x to the power of 5 plus x to the power of 4 times y. So if you take that away, we get minus x to the power of 4 y. So we got to multiply this time by minus of minus, since this is negative, x cubed y. Let's bring down the next term, which is plus 0x cubed. Now these are the placeholders which are important to be placed here so that the process becomes easy. So x cubed y, when you multiply with, you get minus x to the power of 4 and y, and the second term will be minus x cubed y squared. So when you take this, these first two terms get cancelled and we get x cubed y squared. Let's bring down 0 x squared. So now we have to multiply by x squared y squared. Then we get x cubed y squared plus x squared y cubed. So let me push the paper a bit in front. So let's continue the process. We get minus x squared y cubed, bring down plus 0x, right? And then we have to now multiply by minus xy cubed. So we get minus x squared y cubed minus xy to the power of 4. Now if you subtract, you get plus xy to the power of 4. Let's bring down plus x plus y to the power of 5. Now this time we have to multiply by y to the power of 4. So say plus y to the power of 4. So if you multiply by y to the power of 4, what you get? You get x y to the power of 4 plus y to the power of 5. So the remainder is 0. Since the remainder is 0, we know that f of x, which is x to the power of 5 plus y to the power of 5, is divisible by x plus 5. So you can do long division to prove it, right? So therefore, we say therefore f of x, which is equals to x to the power of 5 plus y to the power of 5, is divisible by x plus 5. Remainder is 0, right? That is how you can show it. You can also do synthetic division for the same, and you should get 0 as your remainder. I hope the process is absolutely clear. So those of you who know factor theorem can straight away write down the answer in one statement. And those who haven't learned it so far need to show the division part and check if the remainder is 0 or not. If the remainder is 0, then x plus y is a factor, right? And function is divisible by x plus 5. I hope that is absolutely clear. Thank you and all the best.